Today, I'm going to teach you how to do the shell method. First step is we're going to read the problem. The problem says, if you can't read it, find the volume of the solid created around the areas between the graphs f of x equals the square root of x and g of x equals x squared from 0 to 1 around the y-axis. And right off the bat, we're going to use the equation for shell method, which is the volume equals the integral of 2 pi times the radius times the height times whatever the radius is respected to. So in this case, we're going to be using lines that are, or we're going to use a radius that is parallel to the y-axis, which means we're going to use it with respect to x. So going into the equation, we know that from 0 to 1, the equation is going to be 2 pi times x, which is the radius, and then to find the height, you have to find the difference between the two graphs, which is the square root of x minus x squared with respect to x. So using the calculus that we've learned all year, we're going to pull out the 2 pi because that's a constant, and we're going to take the integral from 0 to 1 of x times the quantity x squared minus the square root of x minus x squared with respect to x. And then from there, we're going to take the antiderivative of this portion right here, and then we're going to solve that from 1 and then 0, just like we've always been doing, and then multiply that result times 2 pi. Or I put off to the side, you could put it in your calculator using the finite integral, and that is how you would plug it in. And then either way you do it, you're going to come up with an answer of 3 pi over 10, or it comes out to about 0.94, and the decimals carry on. And that is how you use the shell method.